All right, so the last topic for our rationals unit is working with something called a non-standard rational. So basically what I'm going to talk about in this section is what happens when we are not in y equals a over x minus h plus k, which is something you would have looked at in the last couple of topics. So what happens when we are not in that situation? We have a couple of things that we need to figure out. And the biggest one is the horizontal asymptote. So without getting into too much detail, the k value is non-existent when you are not in standard form. So something like this graph looks fine. It's a normal standard graph. But what if it doesn't look like this? Well, basically, the biggest rule that we're going to follow here is something called the big number rule. And in calculus, this is actually something called a limit. Limits say that as x goes to infinity, or any other number, but for our case it's going to be x going towards infinity, positive infinity or negative infinity, the y value is going to approach the horizontal asymptote. So what I mean by that is instead of just having k and it doesn't exist, in this case the 5x throws off the rule a little bit. If we plug in some sort of big number for x, a million, a trillion, a billion, going up to infinity, 2 divided by all of that is going to get me a value very, very close to 0. And at the end of the day, we are approaching the y equals 0 horizontal asymptote. As you approach a number like infinity, you're never going to get a perfect number like 0, but what you are going to do is get really, really, really close to it, which is basically what asymptotes do in the first place. As we work through the next couple of quick examples, you're going to notice that the highest powers of x are the only ones that matter as we calculate the horizontal asymptote. So let's do that. Let's work with the horizontal asymptotes in these questions. If I go towards infinity for x plus 1 and 2x minus 2, infinity plus 1 or infinity minus 2 is not going to do anything. So I'm going to ignore those completely and just deal with x over 2x as x goes to infinity. I don't need you guys to necessarily write this part down, but it's just the concept that we're dealing with. The x values will cancel just as they would for any other time, right? Infinity divided by infinity is going to be 1. So that means the horizontal asymptote in this question is at 1/2. A couple more on this page. Y is equal to 2x over x squared for question B. The 4's don't matter. That leaves you with 2 over x. And kind of like this one above, if I go 2 divided by an extremely, extremely large number, x going towards infinity, then y is going to equal 0 for that horizontal asymptote. This has a lot more going on, including multiple x values in question C, but if this is infinity and this is infinity and the rest of it is infinity, I only care about my highest powers. So I ignore the 4x, ignore the 5x, and ignore the 6. That leaves me with 2, and that is my horizontal asymptote. D and E are very similar, so I'm just going to jump over to question F. Y is equal to 1 over x squared for the fraction, but you'll notice that within the fraction we got 6x and 9, which we ignore, but the plus 3 is not within the fraction, and that's not going to be affected by x going to infinity, so that means we actually have to include that plus 3. Y is equal to 0 as x goes towards infinity, plus 3, and that means that the y equals 3 value is your horizontal asymptote. Finally, a couple more different examples. Question G, you're going to be left with the highest powers again, which is 2x squared over x. That leaves you with 2x in this case. Well, if x is going towards infinity and we're not dividing it this time, we're multiplying it, y must be going towards infinity as well, and that means we don't have a horizontal asymptote. It means that in this question, we might have a vertical asymptote, which we do at the beginning, but in this case, unless there's a cancellation or something like that happening in the middle, but in this case, since y goes to infinity, we don't have a horizontal asymptote. And finally, in question H, this is another one with something on the outside, but just be careful with the numbers in the fraction. 4 divided by 2 is going to be 2, and the x squareds cancel. So you actually end up with a 2 plus 2 situation, and that is your horizontal asymptote at y equals 4. All right, the video is going to finish off by drawing one graph. There are multiple graphs in the notes for my class, but the steps that we're going to follow here are going to be really helpful for non-standard graphs. If you go back to the previous videos on graphing in the normal y equals a over x minus h plus k, you'll notice things like mapping notation and a little shortcut that we do, but this is not a standard graph, so we're going to have to come up with something a little different. When I evaluate these questions, I want to look first for, do I have factoring or synthetic division or something like that before I get into standard form? And in this case, I would argue that there's some factoring pretty clearly at the beginning. X squared minus 4 is a difference of squares, so I split it into x plus 2, x minus 2. Unfortunately, we don't cancel anything, which means we're not in standard form. Okay, so this is a non-standard graph. And that's because it's not just x minus h on the bottom, you have x squared on the bottom. The other thing, since we don't have any canceling happening whatsoever, means that we do not have a point of discontinuity, which is asked in the question. And now we can move on to our asymptotes. Well, the vertical asymptote in this case is not just one, there's two. There's two values that I can be dividing by 0 with, and that means I have two vertical asymptotes that I will draw in at x equals -2 and x equals 2. Draw those in on both sides. Okay, and then the next thing that I should be thinking about is the horizontal asymptote. The horizontal asymptote would usually be the k value, but since I'm in a non-standard graph or a non-standard equation, the k value is not the same thing as what we're used to seeing. So instead, I'm going to do the x going towards infinity idea. Go back to the beginning. The highest power of x is going to be x squared on the bottom. And 1 divided by an extremely large number is going to be 0. So that's going to be our horizontal asymptote going across the board here. Y equals 0. There we go. Okay, so we have those values. There's our asymptotes. And now usually, as I mentioned, we would jump into some mapping notation or something along those lines, but that's not really the situation we have since we're in a non-standard question. So that means we are going to do something different. We are going to find, what I usually do is 3 points. I often do the y-intercept because it's a nice easy one to find. And then I do 2 other points after, which I'll describe in a moment. X equals 0, I plug in, is going to be y equals 1 over 0 squared minus 4. And that's going to equal -1/4. So that means this is where my y-intercept is. And if you notice, we're now in that bottom middle where there are asymptotes, so I can actually follow the asymptotes down, which is what rational graphs do. They follow the asymptotes. 2 other points that we can find really depends on what you want to choose. My middle is kind of taken care of because I know that if there's a point here, there will not be a point that crosses over into the other section. So what I'm going to do is I'm going to pick points on the left and right of my 2 asymptotes. Let's just pick -3 and +3 and almost do like a table of values, but just with those 2. So I'm going to plug those values in. I'm going to get y is equal to 1 over -3 squared minus 4. And that's going to equal 1 over 5 for y. And that means I have a point at -3 and 1/5. So let's just put a point there. And now I know that this top left section is covered as they follow the asymptote. And it won't cross over into the bottom left. And then finally, we have x equals 3, which is actually going to be the exact same answer because it's a squared value on the bottom. So there's 1/5 again. This time it's 3/1/5. Again, I can't cross over that asymptote. And I follow like so. What's in solid blue is going to be your actual graph. The dotted lines are your asymptotes. And that is how you graph a non-standard graph.